Thanks for joining me for the Appgate demo series. Today's topic, we're going to discuss attribute-based access control, leveraging platform metadata. So without further delay, let's jump into it. If you look at my screen, I've got a Appgate client loaded up. I'm actually logged in. I've authenticated. I've been served certain entitlements. I could use quick launch icons to launch into these various applications. But I want to dive into some of the details that are a little bit under the covers and show you some different things about the way that we define those entitlements that users have access to. If I look at the list of entitlements that I personally was served, I can see some interesting things. For example, I have an entitlement here that grants me access to a particular DNS name. That's a server in my environment. That's, it's my corp app server, if you will. So Appgate will do that name resolution for me. And I'm controlling traffic using, just regular TCP rules on ports 80 and 443. You can see that denoted there as well. So that's a simple way to define what an entitlement destination might look like using a DNS name. I could also look for some IP addresses. So here's an example of an entitlement that's leveraging an IP address, 10.205.2.110 in this case. That could very easily have been a subnet. So I could, instead of a .110/32, I could have done a .0/24, for example, and that would give me access to every IP address within that subnet. So there's some interesting flexibility that you can do there too. This is not unique or interesting with our product. Lots of our competitors can do this kind of thing too. DNS name resolution, individual IP addresses, and subnets. What is unique is the idea of using metadata to access entities. So let's search in here for something called QA. So here I have an entitlement to QA London in the AWS London region, and it is allowing me ICMP traffic, right? So that's used for the ping command, which is something that I like to use to demonstrate access, because you can see in real time whether or not you have access and when it exists and when it doesn't and when it comes back. So it's an interesting tool to use to show your ability to reach a destination. But I can also define TCP entitlements as well that allow me to pull up websites or SSH or even RDP into a particular destination. But the interesting thing about this particular entitlement is that I'm not using a DNS name or an IP address to define exactly what I have access to. I'm actually using that string that I've highlighted as a query to that AWS platform. So this query effectively says, look for any instance that has a tag with a name of mode and a value of QA in the region EU West 2 in the master account. And so what that does is says, execute this query and return the IP addresses of anything that results from executing that query. Those are the things that Jim has access to. And so it executes that and is able to actually pull that information back. So let's go actually look at the AWS environment and see what instances actually meet that query. So I have my AWS console here. Here's my EC2 instances, but I'm actually pointing to Northern Virginia at the second. So let's flip over to the London environment. So this is my AWS London environment. And sure enough, I've got a couple of instances there, EC2 instances that are running with an AWS tag name of mode and a value of QA. So that means that if I tried to ping this 10.205.2.150 based on that query I just showed you in my Appgate client, I should be able to reach that destination. So let's give it a shot. 10.205.2.150, I can copy that IP address here, go into my terminal window and say ping, paste the IP address, and there it is. I'm pinging that particular IP address. I'm all the way in San Diego, so I'm going all the way to London. So, I'm going halfway around the world to do it. But nonetheless, I'm able to get there and successfully get to it, right? I could SSH to it as well. If it was a Windows machine and it had an RDP server on it, I could RDP to it, again, based on the TCP ports that I've been granted access to in that entitlement. So now the question becomes, all right, that's interesting. What happens if the metadata changes? So the way this is actually working is if I go backwards a couple of levels here and pull up my list of connections, you can see that within AWS London, I am connected to a particular gateway called London 02. When I was issued the entitlement granting me access to that QA-based instance, that query was handed off to that London 02 gateway, and the London 02 gateway is instructed to execute that query on a repeated basis, on a periodic and repeated basis. And so it's up there constantly issuing that query, returning the results. And it found results, and it basically set up in its own firewall rules the TCP 22, 443, 80, 3389 for me to reach those destinations. And it stuck those destinations in my route table so that if I generated traffic to those destinations, my route table would send it into my Appgate tunneling driver and send it up to the gateway to be evaluated. And so that's what's happening. I'm actually able to reach that destination because of that. But because that query is running on the gateway, I can actually go in and modify the metadata, and the gateway will automatically recognize that the result set for the query has changed and make the appropriate adjustments to those who've been granted access based on that query. And so let's go do that, right? So I'm going to leave my ping running. You see it running in the foreground here, but if I flip over to my Appgate or my AWS console, let's change that mode tag, right? Let's change it to prod. Let's just pretend that we've promoted it to production. And I'm going to Alt-Tab back over to my my ping command, and within just a few seconds, you see that my ping command begins to fail. Well, it no longer meets that query, that particular instance, that IP address. It is now mode equal prod in the EU East 2 region, et cetera, right? And so just because of that simple little metadata change, I no longer have access to it. Now, the flip side of that coin is, you know, we adopt cloud in today's modern world for a lot of reasons. One of those reasons is to give us the ability to spin up instances at the drop of a hat. I can programmatically deploy lots of EC2 instances, create new workloads and things like that. Well, what happens if something new pops onto the network that meets this query? Well, let's do the reverse of the demo I just did. Let's change that metadata query, that tag, back to QA. And so if I flip back over to that AWS environment and again, edit the same tag, change it to QA, save it, and then flip back over to my ping command, again, within a few seconds, you see the ping starts to go through. And that's because that gateway recognized that that IP address is now part of the result set of the query, added the firewall rule that's necessary that grants me access on the ICMP protocol, and then modified my Appgate route table, or my local route table, so that Appgate would receive the traffic from my ping command here locally. So that's cool. Inside Appgate, we call that a metadata query or a cloud resolver. That cloud resolver concept is not only applicable to AWS, but also to Azure, as well as GCP. We've also taken that resolver concept and applied it to VMware. So if you've got virtual machines running on a VMware platform, we can leverage that cloud resolver concept against your VMware platform to pull those IP addresses back. The thing that's interesting about it, though, is that the various platforms make different elements of data available to that query. And so for AWS, for example, I can look for tags. Well, tags don't exist in GCP. There's a concept that's similar to tags, but they're called labels. So on the Google Cloud platform, the query would actually leverage the word label. I'm going to look for a label with a name and a certain value. In VMware, for example, there are tags in VMware, but there's also other constructs that exist in VMware, like resource pools. So we've added those capabilities to the VMware query, if you will. So that allows us to define resource pools or even folder structures where virtual machines may exist on that VMware platform. So good stuff. Let's dive into it another direction, right? So you could think of those various cloud environments, and whether they're public like AWS, Azure, and GCP, or private like VMware, you know, those are interesting things that I might want to have access to. Well, what if I could marry up the information from Alumio and correlate that to a user in Appgate? So for that reason, we've created a resolver specifically for Alumio as well. Here's how this demo goes. So I already showed you my list of entitlements. Let's go back to that list and search for Alumio. So here you can see Alumio QA London. And I've got a very similar looking query. I'm allowed TCP up to ports 80 and 22. I'm also allowed ICMP traffic. But instead of that AWS query, I'm going to execute an Alumio query looking for label values of QA and AWS London. So what this means is that I've actually integrated my Alumio PCE into my Appgate environment so that Appgate knows how to issue queries against that Alumio PCE. And then it executes this query and again pulls back those IP addresses and reacts accordingly. So let's see what that looks like in a real example. So if I open another tab here and I go to my Alumio console, this is my Alumio environment controlling access between servers. This is purely the east-west play within Alumio. Let me get logged in here, pull my password out of my vault, and log in. Yeah, so from Alumio, we can pull up the illumination map. Again, the whole idea is not necessarily to give an Alumio demo, but to set the stage for what we're doing. I can pull up that illumination map and see some different characteristics about my instances that I have managed by Alumio. Now, Alumio has a concept called labels. And as of today, they support 4 different labels within their environment. Well, to us, these are those metadata concepts that we can tap into. Those labels exist purely in the Alumio world, but we're issuing the necessary API calls into Alumio to have access to them and pull the right stuff based on the values that we're looking for. There it is, it finally came up. So let's actually change it to draft view so we can see what that looks like. These are the rules that are implemented in controlling traffic between instances in that AWS deployed but Alumio managed world. And so you can see that I've got some applications that are running that are labeled as red. I've got some others that are labeled as blue. I've also got QA concepts and production concepts in here. And I've got a Northern Virginia deployment as well as an AWS London deployment. And so the idea here is that all red applications in QA mode within one AWS region should be able to talk to each other, but they shouldn't be able to talk to other applications, or QA shouldn't be able to talk to production and vice versa. And so you see green arrows within the circles, but then outside of the circles, trying to traverse from one circle to another, you see red arrows because Alumio is blocking that traffic. So when I logged in, my Appgate gateway executed the query and said, hey, give me the AWS London QA instance IP addresses. And if I mouse over it, you see that one of those is 10.205.4.7. That means I should have access to that thing. So let's try to SSH to it. 10.205.4.7. So Appgate is controlling my ability to reach that destination based on querying Alumio and saying, give me the IP addresses of the QA instances running there in AWS London. So I got in, there's my command prompt. I can do a uname -a. You can see that it is an AWS instance, for example. Or if I do an ifconfig, you can see that its IP address is in fact that 10.205.4.7. Now from here, if I try to move laterally to another server, let's flip over here and look at the IP address of the application server in that environment is .8, Alumio is going to control my ability to do that. So if I SSH laterally to 10.205.4.8, Alumio says, hey, yeah, you're allowed to do that because that's also a QA instance, right? So Alumio is controlling that flow. If I pop back down to my .7 and try to go to the production, notice I've got a production, here it is, production database in London at .9, Alumio is going to say, nope, you're trying to do this red line here, and Alumio is going to prevent that from happening. So let's try that real quick. SSH 10.205.4.9. And the answer is you get nothing back. And that's because Alumio is actually blocking that traffic and preventing it from happening, right? So Alumio is doing its thing. So I'm going to break out. I'm going to pop back out to my command prompt on my local MacBook here. But now let's run the scenario kind of like I did with QA. What happens if we actually modify the label on this database so that it's no longer a production instance, but it's now a QA instance? So let's edit the labels and let's remove production and let's add QA. and hit save. So now I've modified that label on that production database and made it a QA database, and Alumio will save. And what will happen is now Appgate will get updated because that gateway is executing that query saying, hey, what instances are out there that are QA instances in AWS London? So that means I can still get to 4.7, right? So try to SSH to 4.7, I'm there. If I back out, I can get to 4.8, but let's try 4.9. So I changed that label to QA, and now Appgate says, yeah, that's a QA instance, so I'm going to let you have access to it. According to Alumio, it's a QA instance, so I'm going to let you have access. So I was able to pop in. And Alumio is saying, hey, it is now a QA instance, so that .9 can talk to the .7 and the .8 as well. So if I tried to SSH, if I pop back in and try to do the same demo I did before, start with .7, and then pop over to .9, 10.205.4.9, Alumio says, hey, you've never been there before, so let's add the fingerprint. And sure enough, there it is. I'm over to .9. And again, controlled completely by Alumio in this case. I know that was a lot of ticky-tacky back and forth from jumping from one host to another, but these are some of the security considerations that a lot of our customers require that we be aware of and take advantage of. Again, combining the east-west traffic control of Alumio with the north-south traffic control of Appgate, and leveraging those labels in Alumio as a source of truth to help define that access north-south with the end users. And that's exactly what we've just demonstrated.